We're going to be solving equations and inequalities that have absolute value symbols in them. An absolute value looks like this. We have two lines with some value in the middle. So for example, the absolute value of -3 would look like this. Now what that means is we want to know the distance away from 0. We want to know the distance away from 0 that this number is. That's what the absolute value is. So the absolute value of -3 is 1, 2, 3 units away from 0. So the absolute value of -3 is 3. Also, the absolute value of 3 is the same thing because it's also 1, 2, 3 units away from 0. So if you notice, if you take the absolute value of a negative number or a positive number, you still get a positive answer. That's because the absolute value is a distance. You can't really travel negative distance. You can only travel positive distance. So the absolute value of a number is a positive number always because it is a measurement of distance. Now, having said that, if we look at the first example here, we have the absolute value of x plus 2 equals 9. Now when you're solving an equation, this is an equation, and we have an absolute value in it, we want to eliminate everything but the absolute value first. So in this case we have the absolute value of x and plus 2 equals 9. So we're going to eliminate the 2. Then we're left with the absolute value of x equals 7. Now here's where it gets a little different than what you've done before. Now what number do you take the absolute value of to get to 7? There's two different numbers. You can take the absolute value of 7 to get to 7, or you can take the absolute value of -7 to get to 7. So the answer to this problem is you will eliminate the absolute value signs and we say x equals 7, or x equals -7. So once you eliminate the absolute value signs, you're going to write two different equations because x can either equal 7 or -7, because when you take the absolute value of either, your answer will be 7. Let's do another one. Example 2. Now notice there's nothing outside of the absolute value symbols. So we're already ready to go. In this problem, we're going to eliminate the absolute value signs and write two different equations. 2x minus 5 equals 7. So the first equation, you write it just like it looks without absolute value signs. The second equation you write is going to look just the same over here. We're going to have, let's do it in a different color. We're going to have 2x minus 5. So it's the same thing here. But now we're going to take the opposite of this side of the equal sign. So we're going to have -7. So we're going to solve two equations. Notice we did the same thing here. We took x on the left, and then we took 7, just like it looks here, without the absolute value, and then we put the opposite of 7, which is -7. Now let's solve these. We have 2x minus 5, so we're going to add 5 to both sides. We get 2x equals 12. So x equals 6. So one of the answers for this is 6. The next one, we're going to add 5. This time we're adding 5 to -7, which gives us -2. And we get x equals -1. So if we substitute in a 6 for x here, we would get 7, the absolute value of 7 equals 7. If we substitute in a -1 here, we would get the absolute value of -7 equals 7. Now to graph this, since it's an equation, if we have -1 here and 6 here, these are closed circles on their respective numbers here. So to graph it, for an equation, you just put a closed circle at the actual numbers. And if we want to graph this one, we'd have closed circles at -7 and 7. In our third example, we have 3 times the absolute value of 2x plus 9, and then we're adding 12 to that, equals 10. So we want to treat this kind of like this whole absolute value is kind of just like a variable. So kind of think of this as saying like 3x plus 12. We solve it in the same order. So we're going to subtract 12 from both sides. And then we're left with 3 times the absolute value of 2x plus 9 equals -2. Then we're going to divide by the coefficient of the absolute value. And we get the absolute value of 2x plus 9 equals 2/3. Now, we're going to stop right here because we have the absolute value of some number equaling -2/3. It's equaling a negative number. As we've already looked in the first two examples, that absolute value is a distance, so the answer cannot be negative. So if you have the absolute value of some number equaling a negative number, then it's not right, there's no solution. So we're going to stop right here. If we end up with something like this, the absolute value of some variable equals a negative number, there's no right answer for that, so we're going to just write no solution. Our fourth example, we have the absolute value of 8n is greater than or equal to 24. So now we have an inequality. There's a little bit of difference between that and an equation, so make sure you pay close attention. The first thing we're going to do, we have to split it into 2 different inequalities. We're going to write it just like it looks without the absolute value signs there. So we're going to have 8n is greater than or equal to 24. Then we're also going to write it as 8n, and remember, now we're going to switch this to its opposite, -24, but we have to flip the inequality on this one. Since we're taking the opposite of 24, we're going to take the opposite inequality, so these two are going to be different. Alright, so now when we solve these, we have 8n, we're dividing by 8, so we're going to have n is greater than or equal to 3. And then on this side, we're going to divide by 8, and we have n is less than or equal to -3. And if we graph this, n is greater than or equal to 3. Here's 3, closed circle. It's greater than, so it's going to the right. And on this one over here, we have n is less than or equal to -3. It's closed circle, going this way. So this is one of those OR statements.
What's up, Mr. Meredith?
Alright, our fifth and final example, we have the absolute value of x plus 3 is less than 5. In this problem, we're going to split this into 2 inequalities. So we have x plus 3 is less than 5. Once again, we just write it just like it looks without the absolute value signs. And then our second inequality, we write the left side just the same, x plus 3. We flip the inequality here, and we take the opposite of the right side. So now we're going to we're going to subtract 3 from both sides, and we get x is less than 2. On this problem, we're going to subtract 3 from both sides, and we get x is greater than -8. So when we graph this one, we get x is less than 2. So if this is 2, this is -8, this is 0. X is less than 2. It's an open circle going to the left. And then x is greater than -8, which is an open circle going to the right. So we're going to end up having one of these guys here. Now this is one of those AND problems. Okay, so we could write this, if we joined all that together, we could write -8 is less than x, which is less than 2. We can join that one together. It's different than the previous example where we had or. When we have or, we can't really combine them all.